This next proof is going to use something a little bit different in terms of reasoning. The instant that I look at this, it's a little bit baffling, but I do see there's promise. So somehow in the numerator, I have 1 plus cosine. However, it's in the bottom there. So that's kind of gross. I don't really like that too much. And yet, here, sine is there and there. Now, don't make too much of that. But there is something that I am considering. What if we multiplied by the conjugate? The what? The conjugate. That is, a difference of squares can be very useful. So watch what I do here. The conjugate's an incredibly useful, beautiful piece of mathematical machinery. But anyways, I'm going to say left-hand side is equal to 1 plus cosine theta divided by sine theta. And by the way, in all truthfulness, I am flying by the seat of my pants. I actually don't know where this is going. However, over the years, I've practiced these and I've sort of developed an intuition through practice. My right-hand side is equal to sine theta 1 divided by 1 over cosine theta. Now, what I'm going to do, and it's going to be weird, is I'm going to multiply both top and bottom by the conjugate of the denominator. Why would I do that? That's a great question. And the answer is really why not? Now, the conjugate of 1 minus cosine is 1 plus cosine theta. Conjugates are really important because when you multiply through conjugate, it turns it into a difference of squares. Furthermore, what maybe gave it a hint? I noticed that 1 plus cosine theta is in fact the conjugate of the denominator. So I'm going to work on, I believe there's a lot of promise on the right-hand side. I could have worked on the left-hand side equally correctly as well. But anyways, what I'm going to do is I'm going to multiply these quantities. So sine theta times 1 plus cosine theta is going to yield 1 minus cosine theta, 1 plus cosine theta, and there is my conjugates, the product of conjugates, and they create a difference of squares. Now, this looks like it's disgusting, but I promise you that we are going to get somewhere really quickly. Now, let's take a look to the left-hand side. I have created a factor of 1 plus cosine theta. I'm going to give you 3-4 seconds to maybe try to see how we could get rid of sine theta in the numerator on the right-hand side. So you may recall, just recall, that actually sine squared theta plus cosine squared theta is equal to 1. Or that sine squared theta is equal to 1 minus cos squared theta. So I'm just going to delete this here. So magically, I can turn 1 minus cosine squared theta into sine theta, sine squared theta. And isn't that so nice? It's so incredibly nice because I can factor, or I could cross out factors of sine theta from both the numerator and the denominator, and I'm left with 1 plus cosine theta divided by sine theta. So, wow, I've done it. If you notice, the left-hand side is equal to the right-hand side, so therefore, left-hand side is equal to right-hand side one plus cosine theta divided by sine theta is equal to sine theta divided by 1 minus cosine theta for all theta. And by the way, there's a cute little symbol if whenever you want to say for all, upside down A for all theta.